Class 11 Physics for HSC, CBSE and ISC students, Chapter 8 Gravitation, and today this is class number 65, Problems on Gravitation. We do here some problems based on gravitation. Gravitation chapter. These are some of the important problems. You see the problem. The first problem, two bodies of masses 40 kg and 80 kg are at a distance of 0.15 meter apart. The force of gravitation between them is 10 milligram force. Calculate the gravitational constant and G is equal to 10 meter per second square, small g. Two bodies of masses 40 kilogram and 80 kilogram are at a distance of 0.15 meter apart. The force of gravitation between them is 10 milligram force. Calculate the gravitational constant G, capital G. Small g is given 10 meter per second square. Solution. The Newton's law of gravitation is capital F is equal to G m2 by r square. G m2 by r square. From this we get G is equal to fr square by m2 on cross multiplication. അപ്പോൾ നമ്മൾ ന്യൂട്ടൺസ് ലോ ഓഫ് ഗ്രാവിറ്റേഷൻ എഴുതിയിരിക്കുകയാണ്. അതിൽ നിന്ന് ക്യാപിറ്റൽ ജിയുടെ യൂണിവേഴ്സൽ ഗ്രാവിറ്റേഷണൽ കോൺസ്റ്റന്റിന്റെ വാല്യൂ എഴുതിയിരിക്കുകയാണ്. And here F given is 1 milligram force. Milligram we can convert into kilogram by multiplying it by 10 raised to minus 6. 1 milligram is 10 raised to minus 6 kilogram force. And kilogram force is the gravitational unit of force that we convert into Newton by Newton. That we convert into Newton. Kilogram force we convert into Newton by multiplying it by G. And G is 10. So we get 1.0 into 10 raised to minus 6 into 10 Newton. 1.0 into 10 raised to minus 5 Newton. That is a force. F is equal to 1 milligram force. We can convert into 1 into 10 raised to minus 5 Newton. M1 is 40 kilogram. M2 is 80 kilogram. R 0.15 meter. 15 meter. ഈ കിലോഗ്രാം ഫോഴ്സിനെ ന്യൂട്രാക്കാനായിട്ട് നമ്മൾ ജി കൊണ്ട് പിടിച്ചാൽ മതി. ജിയുടെ വാല്യൂ 10 ആണ് ഇവിടെ തന്നിരിക്കുന്നത്. So M1 is 40 kilogram, M2 80 kilogram, R 0.15 meter. Substitute. Capital G is equal to 1.0 into 10 raised to minus 5 into 0.15 square by 40 into 80. On calculation we get 7 into 10 raised to minus 11 Newton meter square per kg square. The unit of capital G is Newton meter square per kg square. Next problem. The value of gravitational acceleration G at the surface of Earth is 10 meter per second square. The mass of planet Mars is 1/5 and radius half of Earth. Find the gravitational acceleration at the surface of Mars. ഇപ്പോൾ ഭൂമിയിൽ ജിക്ക് ഒരു വിലയുണ്ട്, 10 മീറ്റർ പെർ സെക്കൻഡ് സ്ക്വയർ ആണ് സ്മോൾ ജി. അത് മൂണിൽ മാർസിൽ കൊണ്ടുവന്നാൽ മാർസിൽ എന്താണ് അവിടുത്തെ ജിയുടെ വാല്യൂ? ഫൈൻഡ് ദി ഗ്രാവിറ്റേഷണൽ ആക്സിലറേഷൻ ഓഫ് ദി സർഫസ് ഓഫ് മാർസ് അറ്റ് ദി സർഫസ് ഓഫ് മാർസ്. മാർസിലെ ആ ജി കണ്ടുപിടിക്കാനാണ്. മാർസിലെ ജി നമുക്ക് കണ്ടുപിടിക്കണം. അതിനിവിടെ ഒരു കണ്ടീഷൻ പറഞ്ഞിരിക്കുന്നത് ദ മാസ് ഓഫ് പ്ലാനറ്റ് മാർസ് ഈസ് 1/5. മാർസിൻ്റെ മാസ് എർത്തിൻ്റെ മാസിൻ്റെ 1/5 ആണ്, 1/5 ആണ്. റേഡിയസ് ഹാഫും ആണ്. So we see the solution at surface of Earth G Earth, G m Earth by R Earth square. E suffix E stands for Earth. At Mars surface G m is equal to G m by R m square. Small m stands for Mars. Dividing 2 by 1, we get G Mars by G Earth is equal to m by me into RE by RM square. That is GM is equal to cross multiply. GM is equal to m by me into RE by RM square into GE. m by me is 1/5. RM by R is 1/2. GE is 10 meter per second square. Therefore GM is 1/5 into 2. Because Rm by R is 1 by 2. So Re by Rm is 2. 2 square into 10. 8 meter per second square is the answer. Next problem. Next problem. Two spheres of mass 38 kilogram and 15 kilogram each are placed with their centers 20 centimeter apart. The force of attraction between them is equal to 0.1 milligram weight. Calculate the constant of gravitation. Here also the milligram force is given. Milligram weight is milligram force. M1 is 38, M2 is 15, D is 20 centimeter is 0.1 meter. Centimeter is converted into meter by dividing it by 100. Force of attraction, F is equal to 0.1 milligram weight, milligram force, that is 0.1 into 10 raised to minus 3 gram weight. That is 0.1 into 10 raised to minus 6 kilogram weight. That is 0.1 into 10 raised to minus 6 into G. G value is 9.8. Since G is not given as 10, we have to take the known value, 9.8. F is equal to G M1 M2 by D square or R square. G is Ft square by M1 M2. Put the values. Capital G is equal to 0.1 into 10 raised to minus 6 into 9.8 into 0.2 square by 38 into 15. 6.88 into 10 raised to minus 11 Newton meter square kg raised to minus 2. A very similar problem. Next problem important. A body weighs 63 Newton on the surface of Earth. What is the gravitational force on it due to the Earth at a height equal to half the radius of the Earth? ഭൂമിയുടെ സർഫസിൽ ഒരു വസ്തുവിൻ്റെ വെയിറ്റ് 63 ന്യൂട്ടനാണ്. ഈ ഭൂമിയുടെ റേഡിയസിൻ്റെ പകുതിക്ക് തുല്യമായ ഹൈറ്റിലേക്ക് ഈ വസ്തുവിനെ കൊണ്ടുപോയാൽ അവിടെ വെയിറ്റ് എന്തായിരിക്കും? ഭൂമിയുടെ റേഡിയസിൻ്റെ പകുതിക്ക് തുല്യമായ ഹൈറ്റിലേക്ക് സർഫസിൽ നിന്ന് കൊണ്ടുപോവുകയാണ്. അപ്പോൾ അവിടെ വെയിറ്റ് എന്തായിരിക്കും? So since weight is given, we can write a mass of the body. Mass of the body M1, that is mass on the surface, 63 by 9.8 kilogram, because weight is equal to M1G. Mass of Earth M2 is 6 into 10 raised to minus 24 kilogram, that you assume. Radius of Earth is 6.38 into 10 raised to 6 meter, or we can take 6.4. Distance D is equal to R plus R by 2, height, that is 3 by 2 R, at the highest point, R by 2 height, that is 3 by 2 into 6.38 into 10 raised to 6. F is equal to the relation G M1 M2 by D square, that is F is equal to 6.67 by 3 by 2 into 6.38 into 10 raised to 6 the whole square, 63 by 98. That is 6 into 10 raised to minus 24. You look here F is, one step is missing. Here F we calculate first. F we calculate on the surface of Earth, and F we can calculate at a height using the mass. One step is missing. I will give the steps at the as the comment. And on calculating weight at a height, we get 28 Newton. 28 Newton. Next question. Calculate the mass of Earth from the following data. Radius of Earth equal to 6371 kilometer, G 9.8. Mass of Earth. G is G by R square, M is GR square by capital G, that is 9.8 into 6371 into 10 raised to 3 square by 6.67 into 10 raised to minus 7. That is the value of G. We get 6 into 10 raised to 24 kilogram. Mass of Earth is approximately 6 into 10 raised to 24 kilogram, but actually it is 5.96 into 10 raised to 24 kilogram. Next problem. The acceleration due to gravity at the moon surface is 1.67 meters second raised to minus 2. If the radius of the moon is 1.74 into 10 raised to 6 meter, calculate the mass of moon. Use the known value of g. For Earth, g is gm by r square. For moon, gm is 1.67 meters second raised to minus 2. R moon 1.74 into 10 raised to 6 meter. M moon question mark. Mass of moon we have to find. So for moon we write the relation g is gm by rm square. G mm by rm square. Mm is gm into rm square by g. That is mm is equal to gm. Mm is equal to gm. It is equal to gm into rm square by g. Gm is 1.67. 1.67 gm. 1.67 rm square. 1.74 less than 6 square by capital G. 7.58 into 10 raised to 22 kilogram. Next problem. There is a point, thus G greater than omega square r. So the object will remain stuck to the surface. Next, assuming the Earth to be a sphere of uniform mass density, how much would a body weigh halfway down the center of Earth if it is weighed 250 Newton on surface? സർഫസിൽ ഒരു വസ്തുവിൻ്റെ ഭാരം 250 ന്യൂട്ടൺ ആണെങ്കിൽ നമുക്ക് പകുതി ദൂരം ഭൂമിയുടെ റേഡിയസിൻ്റെ പകുതി ദൂരം അകത്തേക്ക് കൊണ്ടുപോകാൻ ഇന്റീരിയർ കൊണ്ടുപോയി കഴിഞ്ഞാൽ എന്തായിരിക്കും പുതിയ മാസ്? വെയിറ്റ് ഓൺ ദി സർഫസ് W is mg 250 Newton, m is 250 into 9.8 kilogram. Inside Earth, g dash is g into 1 minus x by r. X is r by 2. Give the value, that is g dash g into 1 minus r by 2r, 1 by 2 g. R and r will cancel, we get 1 by 2 g, 4.9 meters second raised to minus 2. Weight of the body halfway down, mg dash. G dash is 4.9 and mass we have calculated previously 250 by 9.8, 125 Newton. 125 Newton. Next problem. What is the value of G at a height of 8848 meter above the sea level? Given G of the surface of Earth is 9.8 meters second raised to minus 2, mean radius of Earth is 6.67 into 370 10 raised to 6 meter. Answer. Acceleration due to gravity at a height h is g dash g into 1 minus 2h by r. Equation is repeated. 9.8 into 1 minus 2 into 8848 by 6.37 into 10 raised to 6 equal to 9.8 into 1 minus 0.002778. 9.772 meter second raised to minus 2. Next problem. Next problem. On the surface of Earth, a body weighs 99 Newton. What is the gravitational force on it at a height equal to the radius of Earth? Height equal to radius of Earth. This problem we have written previously and now we can see it. On the surface of Earth, G is gm by r square. Mg is 99 Newton. At a height h above the ground, g dash is gm by r plus h the square, where h is r by 2. So g dash by g is r square by r plus h square. That we substitute. H is r by 2, r square by r plus r by 2 square. That is r square by 9 by 4 r square. That is g dash is 4g by 9. Weight mg dash. M into 4g by 9, mg into 4 by 9, mg is 99 Newton given. So 99 into 4 by 9, 44 Newton. 44 Newton. So on the surface, the weight is 99. and at a height h is equal to r by 2, the new weight is 44, and you see the that problem with incomplete steps. You look, we can go to the previous problem, 28 Newton, and this problem is also done in the same manner. You look here 63 Newton, and what is the a body weighs 63 Newton on the surface of Earth. What is the gravitational force on it on the surface at a height equal to half of the radius? The same type problem. So here one slide is missing. The answer I have written here 28, and this can be done as the problem just we read. That problem can be done in this problem. You look here. The problem without sufficient steps, we can complete it by this problem number 8. Number 8, and that is 63 Newton problem. Both are same. When we write steps, the answer will be different. There it is given 63 Newton, and weight at a height is 28 Newton. Here it is given 99 Newton. The weight at a height h is equal to r by 2 is 44 Newton. That is only different. Steps should be in this manner, and this slide is missing in the previous problem. So here look at this page and correct accordingly. Then you get the answer. So no need of separate comment for this class. The problem with the missing data can be corrected by reading this problem. Thank you very much.